Love to have the one and only Harvard astronomer Avi Loeb on the show. And we've been tracking 3I Atlas for several months, but there's something new and very interesting that's piquing a lot of people's attention, getting a lot of people's attention right now. So let's go ahead and bring in Professor Loeb. How are you today?
Thanks for having me. It's a great pleasure to join you.
We always enjoy having you here. Tell us about deuterium. Am I saying that correct?
Yeah, so hydrogen, we all know, is the simplest atom, the most abundant atom in the universe. It has a proton in the nucleus and an electron orbiting around it. But in principle, you could add a neutron, which is a neutral particle, to the nucleus, and it will still be a hydrogen atom, but with a neutron in addition to the proton, and that's called deuterium. It turns out that during the very hot initial state of the universe, about 20 minutes after the Big Bang, there was some deuterium made, and about 1 part in of order 50,000 or so hydrogen atoms are deuterium. So that's a small fraction, 1 in 50,000. But then as we look in the solar system, we find this fraction in the sun, we find it in Jupiter. In the salt water on Earth, the fraction is a little larger, by about a factor of 10 or so. But still, it's a very small fraction of deuterium, but it's easy to isolate it from seawater. And in fact, during the Manhattan Project, Edward Teller raised the question of if we detonate an atomic explosion, would it ignite the deuterium in the atmosphere, in the ocean? Immediately Hans Bethe calculated that would not be the case because of radiation losses, this process will fizzle out. In principle, deuterium is a very good constituent within fusion fuel. When we are doing fusion experiments, and in the future there might be fusion reactors, deuterium and another isotope of hydrogen, tritium, are the best components of fusion fuel. Now, an interesting question is how different is the abundance of deuterium in 3I Atlas? This is an interstellar object that came to visit the inner solar system, and we were able to observe it. And in fact, the Webb telescope detected deuterium in 2 molecules. One is water, and the second was methane. And in both of them, well, in the case of water, 1 in 100 hydrogen atoms was deuterium. In the case of methane, 1 in 30 was deuterium. That's an abundance that is 1,000 times more than you find in the sun and or the planets. And the question is why? Why is deuterium so abundant in this particular interstellar visitor? One possibility that is raised by the authors of these reports is that perhaps this object was produced in very cold environments of ancient stars that formed 10 to 12 billion years ago, shortly after the Big Bang. And the problem with that suggestion is that there is just not enough material in heavy elements to account for the carbon, oxygen that we see in 3I Atlas. There is just not enough to produce a population of objects such that one of those objects will be observed over a period of a 5-year survey that we conducted before we found 3I Atlas. So, and we are missing the mark by several orders of magnitude. And so it's just not clear indeed whether this was the origin. And one should always ask, could it be that the overabundance of deuterium, a factor of 1,000 relative to the primordial abundance, is a technological signature, because deuterium is used as fusion fuel in the experiments that we're conducting.
I am astounded by that. And I mean, when was the last, and what was the context maybe? behind the last conversations that you had about deuterium? I mean, in terms of what we're seeing now versus the last time that you really had a conversation about deuterium being detected?
Well, it's an amazing feat of the Webb telescope that was able to get spectroscopy to that precision to infer deuterium. And we didn't have that conversation until this data was released, and the data was taken just a few months ago. So this is very new. But there are also other anomalies of 3I-ATLAS that are not widely discussed. For example, we do see three mini jets coming out of the nucleus, and they're symmetrically separated from each other. Nobody discusses how come they are so symmetric. And is this evidence for thrusters, or is it just a natural occurrence of pockets of ice on the surface of a rock? And there are also questions about why is the trajectory so fine-tuned to be within 5 degrees of the planets around the sun? Why was there nickel with very little iron detected early on around this object? Usually nickel and iron come in comparable quantities. Altogether, I listed the 22 anomalies about this object. We clearly don't understand much of the properties of this object. It looks very different from comets that we are used to in the solar system. And the one possibility we should always think about is you could have a situation with a Trojan horse, meaning an object that looks completely natural or not unthreatening from the outside, but in the inside it's different. It might have some technological gadgets inside. And of course, this is the story of the city of Troy residents who did not suspect anything, accepted the Trojan horse, and then realized that it's an existential threat for them. So we should always consider that, because if we weren't wanted to reach interstellar space, this would be a good approach. We could plant a capsule of technology in the belly of an interstellar object. 3I-ATLAS is moving much faster than our fastest rockets. In fact, it was near two of our spacecraft, the Europa Clipper and the JUICE, that were launched by the European Space Agency. So it was next to them in November, and it just crossed Jupiter last week. These two spacecraft will reach Jupiter in 2030, 2031, just to show you how much faster it is. And if we wanted to reach interstellar space, this would have been our best opportunity to put a payload on 3I-ATLAS and let it take a hitchhike. In principle, that could be a mechanism by which other civilizations launch equipment to space.
And let me ask you this. I mean, we have been watching 3I-ATLAS for quite some time now. What do you think is next for it?
Well, it's now fading away. And so I summarized 22 anomalies that we had known about it. Now there is the last one, which is the deuterium abundance. I haven't seen the data obtained when it crossed Jupiter, came within 53.6 million kilometers from Jupiter, which is just the distance at which Jupiter's gravity dominates over the sun's gravity. There is the Juno spacecraft near Jupiter that could potentially provide us with the final data on 3I-ATLAS, but that data was not yet shared. And that will be pretty much the best we can hope for, because in the future it would just fade away, and we won't know more about it. It was an amazing opportunity for us to, in principle, intercept it and land on it or extract some materials from it. Being close to it would have allowed us to take a close-up photograph, and that would have told us about its nature. Scooping some material from it would have allowed us to actually study whether there are any building blocks of life as we know it, even if it's natural, even if it's just an iceberg. But we haven't done so because we were not prepared. And so my hope is that in the coming decade, the Rubin Observatory in Chile will be able to identify dozens of objects like it. There must have been a lot of them that we missed in the past because this one was very bright. And it was also aligned with the planets, giving us an excellent opportunity to use our space assets to probe it or come close to it. But we haven't taken that opportunity because we were surprised. So I think the hope is that in the future we'll be more prepared. And that includes building also a counterpart to the Rubin Observatory, because the Rubin Observatory is in Chile. It monitors the southern sky. We want a similar survey telescope monitoring the northern sky. And there is a plan for the Argus array being supported by the Schmidt Foundation. And that could actually cover the entire sky together with Rubin. And in addition to that, we should plan for intercept missions that will be waiting for the next opportunity to come close to an interstellar visitor, because we should never assume that what we will see in the future must be a reflection of what we've seen until now within the solar system. And these objects spent millions to billions of years traveling to our backyard, and it's just a lost opportunity for us not to examine them, because for us to go to where they came from would take millions to billions of years. So nobody is patient enough to make that journey. And these objects made the journey, and so we should check them. And there is always the chance that it's not just a rock, that it might represent some alien technology, in which case it will be revolutionary for the future of humanity.
Oh, you said a lot there just in that last line. So you kind of touched on this when you mentioned, going where it came from. But a lot of people do think that the deuterium suggests or maybe gives us a window into where it came from. Do you agree with that?
Well, so the suggestion is that those level of enrichment of deuterium, and also I should say carbon-12, which is an isotope of carbon-12 relative to carbon-13, if you combine that information that was inferred from the Webb telescope data just this month, then it implies a very ancient environment of an old star that had a planetary system. This material must have assembled into 3I-ATLAS maybe 10 to 12 billion years ago. I should say that the age of the solar system is only 4.6 billion years. So this object must be more than twice the age of the solar system, if they are correct. But as I mentioned before, I did a calculation, and there is just not enough material in those systems that the scientists are assigning 3I-ATLAS to, so to account for a population of such icebergs. So I do think that there is a puzzle here, one out of many, about this visitor. And we should be happy when things do not line up, because they represent an opportunity for us to learn something new. Experts very often want to pretend that we understand everything, so they avoid discussing those facts that we can't figure out. And instead, I think it should be the other way around. We should focus on the things that we cannot explain, because once we collect enough data and we might learn something new that we haven't thought about before. And our imagination is limited by our experiences, and those were mostly solar system related in the past. So here we have an opportunity to meet with visitors and learn what lies beyond the Earth. And I want to mention that in perspective, because in recent weeks we heard from President Obama, who was asked whether aliens are real, and he said yes, they are. But and in fact, when he entered office, he wanted to know if there is a laboratory where the specimen and the evidence for extraterrestrials may be, and he was told there is no such laboratory. But nevertheless, it shows you the level of curiosity. And then, of course, President Trump directed the Pentagon in response to that to release any information, the Pentagon and related agencies, to release any information related to extraterrestrial life and intelligence, implying that there is something that the U.S. government has. This information is currently classified, but it's very puzzling, and I would love to see it and help government figure it out, because obviously, if it relates to national security, we are dealing with objects that behave in unusual ways because we are not aware of what is being produced by adversarial nations. We should figure this out. But if it behaves in ways that humans cannot reproduce, it's even more exciting. And I would love to know more about this data. And as you know, I'm leading the Galileo project that is currently operating 3 observatories. We now are able to figure out distances to objects in the sky, so we can figure out their velocity, their acceleration, and tell whether they are outliers relative to human-made technologies. And I told my research team, if you find anything that looks unusual, you can wake me up at the middle of the night. I'm all for it. And without curiosity, without being open to the possibility that there might be something unusual going on, we will never discover it. And I should also mention, in this context, I wrote an essay on medium.com. That's where you can find all the updates about my work. I wrote a couple of weeks ago an essay about an image from the Curiosity rover that was obtained by several of its cameras from different angles, and they documented a cylinder that is about 20 centimeters in length, roughly the palm of your hand, that a cylinder that was spotted on the surface of Mars at a distance from those cameras on the Curiosity rover. NASA never paid attention to that, and when alerted, they didn't make any comment about that. But that's not really the issue. The issue is we see a cylinder that is clearly not natural. The question is whether it's contamination from one of NASA's rovers, or maybe it tells us about a piece of technological equipment that exists on Mars that has nothing to do with humans. So I would put a high priority of going back to that place. Currently, Curiosity is 8 kilometers away from that location. They can easily go back within a couple of weeks. I mean, even if they move at the highest speed of the rover, they can get back there within a couple of days. But I say let's move more slowly because of the terrain, maybe a couple of weeks. And then, that would be an item of great interest to the public because this cylinder is very puzzling. So why not give it a high priority?
Well, let's see what happens from here. The White House has already registered the domain aliens.gov, and they said stay tuned just the other day. So curiosity is out there for sure. We always learn something new, though, whenever you're here, Professor Loeb. So thank you for coming back.
Thank you. And Curiosity is the name of the rover. And I'm definitely tuned as advised by the White House. So they don't need to worry about me being tuned.
I didn't question that. Not at all. Not at all. All right. You take care. We'll be calling back on you soon, I'm sure.